Yeah, I just wanted to provide a couple of framing comments for Ted. What I hope Ted's going to do is kind of walk us through a little bit of the evolution of how the tech-to-market approach worked on this particular project. And it's one where the team went from really not having a lot of background in tech-to-market to one that's really has a very effective commercialization plan going forward. So we're excited to have Ted here today.
Thank you, Brian and Maury. I'm thrilled to be here. I'm working with Greg Reeker, who's in the room somewhere. Greg Reeker's lab has one of the CU RPE grants, and it's one of the monitor projects that Brian was the program manager for, which is a methane sensing technology. And so I'm going to talk generally about tech-to-market and how RPE describes tech-to-market, so it'll be some just the abstract concepts, and then and try to illustrate those with some concrete examples from our project. So an engineer walks into a bar, and he meets a woman, and she turns out to be a venture capitalist, and he goes, "That's great, I have an invention, and I think you should invest in it." And he goes on to describe his invention, and it has something to do with quantum mechanics, it has something to do with nanotechnology, it has something to do with blockchain analysis, it has something to do with cloud computing, there's a little bit of big data, it's got super cooled electronics, or maybe it's super cool electronics, anyways, it's super high tech. And the investor goes, "Oh, that's interesting." And she walks away, and she goes to the bar, and she doesn't say, "Call me," and she doesn't hand him a card. So what just happened? Well, the engineer did what engineers like to do. They described a technology. And with the mistaken impression that investors invest in technologies, which they don't do. What investors do is invest in businesses. And there's a difference. And what's fantastic about the RPE program is it requires teams to move two things along together. You need to invent a technology, but at the same time, you need to create a business to deliver that technology. So what happened in that transaction? Well, if you look at that little cloud at the top, what does it do? The engineer might have talked a little bit about what it did. If he could have got beyond the technology and the in-depth technological discussions of how fascinating the technology was, because the investor probably had an engineering degree, but probably doesn't understand the details of the technology. But there's a whole slew of other questions that investor is interested in. One is, if you back up to the left there, it's not the technology, not what does it do, but what problem does it solve, right? A business solves problems and can create a business case. Who has these problems? Who are the companies or people who have these problems who might spend money to fix them? What are they doing now to address that problem, or what's creating that problem, or do they have another solution that's less optimal? What's it going to cost you to deliver that your new technology, and is that competitive? Can you deliver that at a price that somebody's willing to pay? How raw is this technology? How long is it going to take for this technology to come to market? What kind of risks are involved between what we know today and by the time you get to the market? How many resources are going to be needed? Those are the kind of questions that investors are interested in, and those are the kind of questions that your program manager will require you to address as you get involved in an RPE project. So RPE has two parts, or two acronyms actually that are combined that you'll hear a lot about. Brian already mentioned this morning T2M. T2M, Technology to Market Plan, is really the business case. It's answering all those questions that investor would have to convince yourselves and the RPE team that you have a viable business here. And one of the answers to that might be, Brian gave a great example this morning, I hadn't thought of that, but the answer might be, no, there's not a viable business here. And everybody's better off if early on you come to that decision and part ways, before you start investing your retirement fund, your grandmother's retirement fund, other people's monies in something that really doesn't have a business case. And the second piece, which is really a subset of the overall tech-to-market plan, is TEA, Techno-Economic Analysis. That's doing the unit economics to show what it would cost to deliver your technology, and is that cost competitive to make a viable economic case. So I'm going to walk through each of these parts. So here's a schematic that RPE puts out that puts into place and gives you a framework for 6 parts to a tech-to-market plan. On the right are 3 foundational questions. The first is, what is the technology? What does it do? What kinds of problems does it solve? How does it work? The second is the market. Who are the people that would buy that technology? What would they be? What are they doing now? What would they be willing to pay? How do they make decisions about buying technology? And then the third is the manufacturing piece, which really is the TEA. So first of all, you have to figure out, how will I go about manufacturing this at scale? And that will drive costs, and that will drive this unit economic analysis of, are those costs competitive, and can I create a viable business out of that? With those 3 foundational questions, there's 3 others on the left there that are more around the business. The team, so what team would be required to deliver this in the market? Intellectual property, what kind of legal protections do you have about your ideas that will allow you to capitalize on them? And then finally, funding. How are you going to raise enough money? First of all, how are you going to figure out how much money you need, and then raise enough money to provide the resources that will create this business until it becomes a viable going concern. So I'll walk through each of these pieces and give you some examples for what we did with the Reeker Lab. So starting with technology, I don't need to give you a lot of abstract on that. I think that's, again, most of the people in the room are probably engineers. You understand about technologies and how things work. That's the thing you talk about when you're talking to investors in bars. So I will talk about LongPath technology and the Reeker Lab's solution in the monitor program. So we have a open path laser solution that finds methane, and it's one of the monitor projects. So methane is 10% of the world's greenhouse gas problem, and most of the methane it comes from leaks from oil and gas facilities, and most of that comes from oil and gas wells, like those throughout northern Colorado. And so we have an open path laser solution that sends this very specialized laser over very long paths, multi-kilometers. And we can put it on a tower, we can spin it around, and if you do the math, on a 2-kilometer radius, that's about 5 square miles. And basically, we can find every molecule of methane that passes our laser paths in that 5 square miles. So that's technology 1. Technology 2 is we have some analytics that figure out where those molecules came from. So we can tell you which of the wells in that 5 square miles is creating the leak. This technology was invented right here in Colorado with teams at NIST and CU. Jan Hall actually won the Nobel Prize in 2005 for the core laser technology, which is something called a dual comb spectrometer, which is a very specialized technology. You can take one laser and turn it into many, many lasers. They're highly precise, highly powerful. This is a picture from the paper that Greg wrote in Optica, which is the first commercial first application of that core technology. They put a laser on the roof of the NIST building and shot it out 2 kilometers and measured a number of gases simultaneously, a number of greenhouse gases. So we can simultaneously measure carbon dioxide, carbon monoxide, methane, ammonia, water vapor, and other molecules at the same time. The device that did that experiment would have taken up, maybe an eighth of this room or something. It was a big laboratory device. It was a little sensitive. Greg always says that whenever you slam the door, you had to go back to square one and start over. And his team, in the course of this RPE project, has turned that into a device that's about as big as a file cabinet. And it can sit out in a field that's dusty and icy and rainy and snowy and cold around oil wells and work continuously for months at a time. In the process, they've shrunk it by a factor of about 10 in size and about 10 in cost. And we started to get some field results from the device. Brian mentioned that the monitor team built this test facility up outside of Colorado State called the METEC facility. And this is a picture of it. In the foreground there are some, we call them Hollywood well pads. So those are devices that you would see in a real oil well. They're not hooked up to real oil or gas underneath the ground, but they are hooked up to a series of tubes that are connected to methane tanks, so they can release leaks all over this site. We're set up a kilometer away in this picture. So if you see that little blue dot in the upper left-hand corner, and there's a set of trees above that blue dot, that's where our device is. That's how far away it is. And it's finding very small leaks on these well pads in the foreground here. And then again, to get the full scale, that's just the radius, right? It's the kilometer. We could, if we spun it around, we could go just as far in the other direction and find leaks in the other direction as well. So Greg's team has taken a technology that works and done a bunch of inventions to make it a much more commercially robust and economic device that we think can work in the market. So the second piece of the T2M analysis was to figure out that market. And that has a number of steps. One is customer discovery, going out and talking to customers and players in the market to understand the market better. From that, we developed a target market. So who are the potential customers that we would be most likely to be able to sell to? We did some market sizing around how many of those customers are there. Are they big enough to create a viable business? And then finally, we did a competitor analysis because we're not the only one in the market. There are other companies coming in, and they're addressing this in different ways. So starting with customer discovery, we talked to a lot of people. So if you look at this, I guess we have over 100 people now in our contact database from over 60 organizations. And this is, you can't get around it. And for many engineers and professors and laboratory people, it's different than your day-to-day job. Usually you go into your lab and you're focused on things you can control inside your lab. This involves talking to people outside your lab, your strangers, trying to understand their business. But really, it's the only way to understand how this technology is going to solve people's problems. And again, that's the core thing that the investors are looking at and what you need to make a viable business. From this, we were able to create a target market, and I'll walk through some of the list on the rows of that we had before. So if you think about how oil and gas is produced, it goes down this value chain. So first it's produced, so there's an oil well. Production is our oil and gas wells out in the field. And then it goes to these midstream facilities, so it gets piped to these facilities that take out some components and turn it into pipeline-grade gas. Then it goes into a pipeline, and it gets shipped to city centers. Along the way, it might go into storage fields, where they can store gas in the summer when it's cheap and release it in the winter when it's more expensive and more and there are shortages. And then finally, it goes to distribution utilities like Xcel Energy to get piped out into businesses and homes. So we talked to companies all along this value chain to understand, how is methane leaks affecting their business? What kind of business processes do they have right now to address this? And how would our technology fit into that? From that, we put midstream on the shelf. It's a different technology. We think we can adapt our technology to that market, but there aren't that many of those players, and our technology wasn't the perfect fit for our technology, at least right out of the gate. We kind of eliminated transmission. Those are long linear pipelines, and while we could develop a linear solution, there were other reasons that pipeline companies were using their existing technologies, some of which is they like to actually look along the pipeline and see with their eyes or with cameras about what else is going on along that pipeline, and we couldn't provide that. We could just provide the automatic monitoring. And we put distribution monitoring on the shelf as well. They're much more complex systems. These are smaller pipelines that are underneath every road and building in large cities. And again, we think that we can develop solutions for that. But in the near term, we want to focus on production. There's many oil and gas wells. We definitely have solutions that can work in that area and these storage facilities. We also came up with 2 different deployment techniques. So again, our basic technique is we put a device on a tower. It's a permanent fixed device. It provides continuous monitoring. There are advantages to that. But we can also put this thing on a truck and move it around. And there are economic advantages to that. There are some trade-offs there. The fixed solution provides a better environmental solution, but it's more costly. The mobile solution is more economic, but doesn't provide continuous monitoring. With that understanding and focusing on the production market, we then went out to try to understand, well, how many of these wells are out there, and how many could we monitor? And again, is that big enough to create a viable business? So we created this GIS analysis, starting with Colorado and then extrapolating to the whole United States. So every one of those little dots is a 2-kilometer radius circle. And we put those dots all over, and every place there was at least one oil well in Colorado. And then we mapped the densities of those. And so those densities go from, you can see down there in the corner, a couple of wells in 2 kilometers up to dozens and even hundreds of wells in the densest spots. And the more wells that are covered, the more economic our one device is, because we're spreading it over more customers. So we have a better value proposition. And then we varied that a little bit. So this is a 5-kilometer circle. So there are less spots, so less customers, but we could cover many, many more wells, and a more economic solution. And when we're focusing on kind of 1 to 2 kilometers as we enter the market, we're already working. NIST has already been has already had laboratory tests of this device on lengths as long as 5 kilometers. And in our next 2 years under the Monitor project, we will be developing field devices that have 5-kilometer ranges. And then we did similar analyses in all the other states. We did some other segmentation that I won't go into, but in great detail. But as you can imagine, our solution is better if it's flat, right? If there aren't hills in the way. It's better if there aren't trees in the way as well. We think we actually have solutions to some of those as we get down the road. For example, we can put devices on the tops of hills, and we don't have to actually see every leak. We just have to find the plume that is coming off these leaks and have that plume cross our paths. But it's definitely easier to explain, and it's easier for us to deploy in flat states. So we segmented the world into flat states and not flat states. A second driver is regulation. Colorado has been a leader. It was the first state in the country to have regulations requiring oil and gas producers to monitor methane, using techniques that are more expensive and less effective than ours, but there are requirements that they do something. And there are other states that have regulations or are bringing regulations online. So we broke the world up into flat states, flat regulated states, regulated not flat states, and unregulated flat states. And you can see the counts there. And we counted up, where are the devices, and are there enough? Where are the potential customers? And are there enough potential customers to get off the ground in our most attractive market? And the answer is basically yes, and that encouraged us, and we kept moving forward. Finally, it's not just about us. There's a whole bunch of other companies that are in the market. So we're trying to understand what those companies are and where they fit in. This is a map that just shows different deployment technologies. So there are some companies that have very tiny devices. They can put tens to hundreds of devices per pad. We're at the other extreme, where we have one device that covers tens to hundreds of pads, and there are other devices in the middle there. And here we rank it by cost. We can rank it by other approaches as well. Here's a similar 2x2 matrix. And we really feel like we're in a sweet spot, because one way of looking at the market there are these solutions that cover very large areas, like planes and satellites. They can cover very large areas, but they have pretty low precision. And there are other devices that cover pretty small areas with high precision. And we're in that sweet spot in the upper right, where we cover pretty big areas with very high precision. So we think we're unique in that area. So those are some of the market pieces that we did. Then moving on to the manufacturing piece. Starting off with how are we going to manufacture it, and so what is the approach? What would we do internally? What would we outsource? And using that to come up with a set of costs, and then using those costs to figure out, can we be competitive? So we priced out all the parts that have to go into this device. We talked to a lot of suppliers about if we bought and manufactured at volume, how would prices change. You can see here there's a few parts of this that we get not huge, but noticeable discounts on. So if we can get up to around 100 devices and order parts in that volumes, we get some sizable discounts. We then applied this. So our basic economic proposition is we cover lots and lots of wells with one device. So how many wells do we need to cover to drive down this exponential curve? So if you see here, the x-axis there is how many wells we cover within that 2-kilometer radius. And we've got two solutions, the fixed permanent device that's on a tower and the mobile device that we can move around. So the mobile device is cheaper because we take one device and we can ship it off to many deployments per year. And if we can cover more and more devices, it just declines exponentially. That red line is a target price that the monitor program managers put out for us. And as you can see, as we get down into just about 10 or so wells per 2-kilometer radius, we have pretty competitive pricing. We did a number of sensitivities around this to try to understand what drives our costs and what kind of risks are there and where we should focus on our efforts on driving costs down. So here's an example of one of them. The way this works is we put these mirrors out in the field, these retroreflectors. So we shoot the laser out, it hits a mirror, and it comes back, and we do that reading back at the source. And it turns out, we need a lot of mirrors, and there's different quality of mirrors that are out there, and we have actually working with some other teams at CU. We have some ideas about inventing some new mirror technology with polymer paints. And so this just shows, if we can drive down that cost of the cost of the mirror to these higher technologies, how much does that lower our overall solution costs? We're also looking at, instead of putting out fixed mirrors, mounting mirrors on drones, and we can fly a drone around with one mirror. How would that compare to putting fixed mirrors out in the field? Turns out, at least for the foreseeable future, you need to have a pilot to fly a drone, and so depending on the cost of that pilot, right now with what it costs for drone pilots, it's more expensive than having fixed mirrors. But if we can drive those costs down in the future, there's a trade-off at what point the drone solution becomes competitive. So those are the kinds of things we did in the TEA, the techno-economic analysis. As we went through that, again, those are the threshold questions. We answered those threshold questions. We have a technology that works. We keep deploying it in the field. We keep advancing the technology, having longer ranges, more precise precision. It seems to be working. We're hitting the threshold question there. We've talked to a lot of potential customers. We've focused on a target market in the production and storage markets. We've begun to understand how they make decisions, how this would fit into their business process. We're working with partners in the field in both of those industries to incorporate our technology into their business. And then finally, we've done the economics, and we know how much it would cost us to deploy it, at least initially. We know how we can drive costs down in the future with volume purchases and with some different approaches to manufacturing. And we understand that we can deliver a cost-effective solution. So then we need to move on to how do we turn that into a business? And those are the things on the left. So the first piece is the team. So who's going to be on that team? So here's a quote from Brad Feld, who's with the Foundry Group here in Boulder, and he's one of the founders of Techstars. Talks about, it's not just the idea, but it's a team to deliver that idea. Brad also has a great saying about his top 5 things he looks for in an investment, and they are team, 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 and idea. And again, it's not the idea. Investors don't invest in idea. Sorry, it's not just the technology. Investors don't invest in technologies; they invest in businesses. And a key part of running a business is having a team that knows how to deploy it, knows how to create the technologies, but also the other parts of the team to build the business and bring it into the market. Intellectual property. These are ideas that you spend a lot of time and effort developing, so you need some protection so that once you go into the market and your ideas are out there, that you have protection that people won't copy them. We've worked very successfully with the Tech Transfer Office here. I'm sure all of you from Colorado State and Mines also have the Tech Transfer Offices there are also very helpful, and they've helped us develop 2 patent applications that we have so far, and we're looking at additional patents. And we're looking at other strategies around trade secrets and other ways to protect our intellectual property. And the final piece of the RPE rubric is funding. And so as you go from idea to business, business is going to take money to get up and off the ground. Even if even if you've got everything in place that it will become a going concern, there's a run rate you have to get to there. So how much funding do you need, and where is that funding going to come from? Some of it can come from additional grants, but there are other sources as well, and some of those are investors, and investors have requirements. And so understanding the investor community, understanding what it is they need to put money into your company, they're going to buy a piece of your company, you're going to lose some control over your company, and understanding how that works and what a good match what a good match is. Oops. At RPE, they talk about month 37 all the time. So you typically get a 3-year grant. That gives you 36 years of funding, which is great. What RPE wants is not for you to spend 36 years of funding to have invented a nice technology. It's to in the 37th month have a viable business that continues on, and that means that you have to have secured the funding well before the 36th month, so that there isn't a drop off there. And again, in the end, you need to create a company, and that's a startup. And this is just a bullet list of the kinds of things you need to do. But the first is incorporate. You need to create an entity that is incorporated in a state. It's got a board of directors. It's got officers. It's got a set of bylaws. It's got shareholders, and it knows how to operate in the incorporation space. You need a place to work. So you need to rent space out in the market, or secure some space inside of your university if there are cooperative arrangements that you can make. You need to create an operations team. You need to go from I put R&D at the bottom. You want to keep doing R&D, but you need to go from an R&D organization to a delivery organization. So you need to have sales people that are out there signing up customers. You need to have an operations group that are delivering solutions to customers. You need to have customer care that are dealing with those customers. You need a back office. You need finance. You need legal. You need HR. I think that's all my list. Fortunately, there's a lot of resources. So here's a list from CU that we found out about and we're working with. To either a minor or a major event. I want to just call out a couple of them. The Tech Transfer Office in particular, they've been very helpful for us with all the intellectual property, and also being a quarterback and introducing us to all these other organizations. The Entrepreneurial Law Center. Let me just get through this. This is my last slide, and then I'm going to open it up for questions. So Brad Bernthal's got a great group of law students that will help you with incorporation documents and help you get set up. The Innovation Center of the Rockies, which this is an old slide because it is now merged with Innosphere. And again, the Tech Transfer Office works with them, and they paired us up with them, and they've been fantastic, up and down the board on all the kinds of pieces that I went through on the T2M analysis. And extremely helpful in hooking us up with individuals and just networking within the Colorado startup community. I think those are all the ones I haven't read. And that's it for me talking at you. But I did want to open it up. Brian had asked me to run through what we did, but really respond to questions or comments from the audience.
What was the difference between the red checks and the black checks on that last slide?
Those were they were just organizations that I wanted to highlight and say a little more about. But I could say something about all the other parts of them as well.
Question?
Over here in the second to last row.
What about regulators?
Oops, sorry.
And your customers?
Here you go, sir.
If you have a customer in California, for example, and they find a leak, they're required to fix it. All leaks. Now, it's a 90-10 situation. 90% of the leaking methane comes from about 10% of the leaks, if you discount Aliso Canyon.
Yeah, so I'm going to answer that with a couple of pieces. First of all, regulators are extremely important in our business. The market is being driven by regulation. As I said, Colorado was a leader in not only the country but the world that put out regulations that have since been adopted sort of by the EPA, depending on what week it is in the Supreme Court. Some of those are applying at the federal level or are not. And they've been picked up by other states and other countries. So this is a regulatory-driven market. And we're focusing on that. That turns out to be an issue as we talk to some investors. Some investors are not interested in investing in regulatory-driven businesses because they feel like those regulations can change, and that's a risk that they would rather not invest in. So our goal is to find investors that understand this market and understand that these regulations are unlikely to go away, and that understand that it is driving this business. So that's the piece, from the inside. You also talked about just the nature of methane leaks, and you're right. There's a term called super emitters in our business, and so that's right. There's a 90-10 rule. Something like 90% of the methane is coming out of these very large leaks, which is why we think it's extremely important to have continuous monitoring, which is what we provide with our fixed solution. So if you have continuous monitoring and you can find that super emitter immediately and fix it immediately, then you go a long ways towards fixing the problem. So we think our solution is definitely preferable from a environmental point of view. The problem is in some cases the regulations are written in a way that it may be hard to capture the value of that environmental value. The good news is here in Colorado they just updated their rules, and it does seem like they are really trying to foster continuous monitoring and foster solutions that will lower overall emissions and will allow companies to make trade-offs where they spend more money to focus on the big emitters and find them fast, and therefore can spend less money on chasing around a bunch of little leaks and spending a lot of money meeting the regulations where that won't necessarily be reducing overall pollution. Maury's got somebody in the back. I'm going to let Maury pick out the people and hand the microphone to them.
Hi, Ted. My name is Jim Bryant. You're talking about this being a regulatory-driven opportunity, but isn't this also an asset optimization opportunity for the industry? I mean, because they're losing valuable resource.
No, that's definitely true.
Yeah, because it's kind of a dual sell, not just a regulatory-driven thing,
No, you're right. And I probably overstated that. And so every time we talk to an oil and gas producer, and first of all, it's not, well, like you said, any molecule of methane that's going up in the air is a molecule that's not going in the pipe and they're not getting paid for. But that's actually only the second most important thing to them. The first most important thing to them is safety. This is a dangerous it's a dangerous situation. They have their workers and their communities are surrounding these wells, and they are very interested in making sure that they run safe facilities and they're good corporate neighbors. But it's also true that in the states where there is regulation, there's a different economic trade-off. So if you're in Texas, the trade-off is what's the probability that I'm going to find a leak and I'm going to put those molecules back in the pipe, and that's one economic trade-off analysis. In Colorado, it's I have to do leak monitoring already, and so can I do leak monitoring that is cheaper and more effective? So it is a different economic choice in a regulated state.
So Ted, I wonder if you could just walk us through the process a little bit on developing the T2M team. So, it's very mature commercialization analysis. You've launched a company, but when the project was selected and started, there wasn't expertise on the team in commercialization.
Yeah.
So how did you get from that zero state to where you are now?
Well, I can only, you might be able to tell the story better than I, because you were there when this team started, and Greg's not in the room anymore, but I've heard the story enough times I can repeat it, which is Greg proposed to Monitor that he and his technical team that had very impressive credentials and a lot of papers and a lot of they had a lot of horsepower on the technical side, and they proposed that they would hire an MBA grad student to do the T2M analysis. And in the first meeting with Brian and the rest of the program management team at Monitor, they were informed in short order that was not going to be acceptable. Again, the RPE philosophy is you don't just create technologies, you create a technology and a business at the same time. And he needed a more seasoned team. And so Greg found me. I actually didn't know him. He wasn't in my network, but I was speaking at a conference here at CU, and he was in the audience, and he came up. This was a week or so after he had sat down with Brian, and he came up and found me, and so we talked. And so I've been in management consulting in the clean energy business for 35 years, and I'm pretty active in the startup ecosystem here in Colorado, and so I was a good fit, and I knew a lot about economics and about startups, and I didn't know anything about lasers. And I knew a fair amount about the energy business, but I knew more about the downstream energy business. So most of my career has been with utilities as opposed to with oil and gas producers. And so I had a learning curve I had to come up as well. But it's been a nice combination with the technical team and myself. I brought on some other partners that have helped us. So I brought on a guy who did that GIS analysis. I brought on some people to do some economics, and it's been a good fit.
So there's different pathways for every type of project. Some of the projects are small businesses, so they have that commercial intent baked in. Other cases, it's universities. Some have those capacities on the team. Other cases didn't have that, and in this case, they were able to go in and bring it onto the team. We also have other cases where you may have a large business, which isn't always, and one of the challenges is a large business isn't always entrepreneurial. So it's really, there's a real continuum, but the important thing is that it's a very important part of the project to have a viable path to commercialization. Okay.
Hi there.
Hi,
Quick
Kate.
question. Is this being tested in the field with any operators at this point yet?
Yeah. So we have two partners.
Okay.
One in the production space, so an oil and gas producer, and a second in the storage space. And so we've got permanent installations, and which allows us to do two great things. One is to get real long-term field experience, and again, we've only been around a couple of years, and having that continuous experience is helping us refine the technology. But more importantly, we're working with them on understanding, how will this fit into their business processes, and how do we create a viable solution for them, which allows us to create a viable business.
Great. And one follow-up or associated is, are the in the production space?
Uh-huh.
Can you tell me whether the testing is occurring in a densely produced area where there are a lot of different companies, or one company in a broad area?
It's highly dense space. It's mostly one company, but there are other producers around there.
Okay. Thank you.
Yeah. And we're also testing, as we said, we're testing up at the METEC field site as well.
How does this process evaluate the changing business that your potential customers going? Your map showed all those producing wells.
Right.
Oil and gas has gone 16 wells per square mile to now one well pad draining 9 square miles. So that really reduces the number of customers per circle. Is that an impact that's already been baked into this?
No, absolutely. We're working on that. So we've evolved from just counting wells to counting sites, because a site is a pad, and a pad might have multiple wells. And also incrementally, you're right. The new wells have many more. Sorry, the new pads have many more wells per pad, but most of the infrastructure is old wells. So it really is. This is not a. And especially our solution. There are other providers out there that would go to one well. They put small devices on one well, but because we're covering multiple wells, our solution really is to cover the existing infrastructure, much more than the new infrastructure on the margin. But that's an excellent. And we've also found just the way they set up wells in Colorado is different than the way today is different than they set up in California 20 years ago, and different, turns out, than they set up in Texas today. Even within the same company, there's like the Texas approach and the Colorado approach. So we're really learning, you know, the way they run their business, you know, our solution varies depending on, you know, how they have structured their business and how they've structured their infrastructure.
Yes, so this is more following Brian's and yours comment before, is where, and this may be more related to the next topic, about when you're writing your RPI proposal, where does this come in place? Because there's always a space for tech to market transformation or something like that. And maybe I missed something at the beginning, but when I look in the presentation, I was like, this is really interesting, but there's no time to do it when you're writing a proposal, right? So neither resources. So what is the ideal place where we bring somebody like you to the team? Is it after you get the grant, or is it before? I mean, what would you recommend?
I might let Brian answer that rather than me.
So what you really have to do is create a credible story, and some of the in some ways, from a commercialization standpoint, RPE really likes small businesses because they're hungry, and their existence depends on getting this technology developed and into production. When you've got someone like a university team, it's more challenging, and that's what, you know, in many cases, a partnership with someone who knows how to do this, whether it's a small business or a large business, you know, brings that onto the team. So in the ideal case, you would have great technology, and then you would have a defined mechanism to get it into production. Now, there's a lot of things like the techno-economic analysis that you will need to do a little bit on, because at some point you have to say, this is what the technology is going to cost. This is whether it's, you know, dollars per site per year or electricity levelized cost per kilowatt hour. You need to do some of that, but it's recognized that that's a part of the project. And so in the case of most of these projects, we would require techno-economic analysis, and it's updated every quarter. So the first quarter, it's a spreadsheet with a lot of hand waving, but as the technology develops, we're expecting that to become more and more detailed. So it's, as much as anything, describing the process of how you're going to address all these different issues.
Over here.
Have you engaged with Southern Cal Gas on the Oviso Canyon where they had the big leak a couple years ago?
So we've only dealt with the distribution utility side of Southern Cal Gas, not the storage people personally. But we have worked with some partners. We have a good partner, a company called Scientific Aviation, which is it's an airplane that flies over, and he did most of the work on monitoring that disaster while it was happening.
Well, I know they have a lot of ongoing requirements to monitor.
Yeah. One of the reasons we're focused on the storage market is because in California, storage fields have much more stringent requirements than storage fields anywhere else, and so the economic driver is larger.
Okay. Thank you, Ted.
Thank you.
Really appreciate those insights.